Cool. Hi, everyone. Thank you so much for coming today. So my talk is an active record rewrite, the story behind the attributes API. So this talk is about a large active record rewrite that happened in a previous version and the story behind it. So my name is Tess, and today we have a story about refactoring a large part of active record to make it more stable. So first we have this user class. This is its table. It has an integer. It has an attribute ID whose type is integer. So here we have an instance of user. We're setting its attribute ID to the string 1. Now let's call ID on this instance of user and see what's returned. You might expect that calling it again would return the same thing, the string 1. But we actually get back an integer. Its previous type, string, was cast to integer. This is typecasting, turning the data from one type to another and vice versa. So when we look back at our table, we can see that the type for the attribute ID is integer. That's why when we passed it the string, Rails cast it to be an integer. So how does Rails handle typecasting? In Rails, the attributes API handles typecasting. In Rails today, the attributes API has been extracted to active model, but it started off in active record. So for today's look into the attributes API, I sat down for a conversation with its author, who's actually my wife, Sage. Sorry, this is the plant Sage. Tess Griffin is my wife, and during the early years of our marriage, they got into open source contributing and refactored so much of ActiveRecord that I wanted to give a talk about it. So for context, this refactor took place between 2014 and 2016. The major internals refactoring was released in Rails 4.2, and then the public API was released in 5.0. So my first question to Sage was, how would you describe the attributes API? And they said, it's the code that does the types in ActiveRecord. And then I asked them, what is typecasting? And they said, when ActiveRecord receives your data, it's almost certainly going to be a string. But you, as the developer, don't want a string. You want an integer, or date, or whatever useful Ruby object that data is representing. The attributes API and ActiveRecord will deal with converting from your Ruby objects to string representations and vice versa. So I asked them, where did the inspiration for this change come from? And they said that we run a project and had an attribute that needed to be encrypted. We wanted it to be that whenever you accessed it, you got the decrypted version and vice versa. We were using a gem, and I looked at the gem's code to see how it was doing that. Keep in mind, this was back in 2014. They said that the gem was pretty buggy, but I discovered that looking at the code, how much of the Rails internals it had to monkey patch to do this work. And that wasn't the gem's fault. The gem had to monkey patch all these different codes paths. These are Rails internals, so it means that they are undocumented and interact in subtle ways. This is very difficult to get right for gem authors. Supporting multiple versions of Rails becomes difficult or impossible when you're monkey patching Rails internals that aren't stable. It's like building on top of shifting sand. It can change between versions without warning because you only need to give warnings if the APIs are external and public facing, but they were changing Rails internals. And Sage said, I thought that there had to be a better way. And I said that they sounded like an infomercial. And they said, yes, exactly. I was the person in grayscale doing things the old hard way. I was the person trying to cut their bread with a doorstop. There had to be a better way. Rails should make writing this gem easier. Gem authors shouldn't have to monkey patch all of these undocumented Rails internals to get typecasting of encrypted attributes to work. So I asked them, how did typecasting work before your refactor? And they said, poorly. So this was our example of typecasting, taking the string 1 and casting it to be an integer. Typecasting has 3 general areas of work that it does: writing, reading, and saving. So to show you how ActiveRecord handled typecasting before the refactor, we're going to follow the code path to writing the ID attribute. It's going to be great. Okay, first module, write RB. This is write RB in ActiveRecord base. So this is the write module in ActiveRecord base. I have a module counter here. So write attribute takes the attribute name and value, which in our case is ID and the string 1. Oh wait, hang on. Write attribute actually gets overwritten in a different module, in dirty, our second RB, our second module. So we have write attribute again. It casts the attribute to string, and then it saves it, and then it calls super. Neat. Okay, back to write RB module. Okay, so we have to resolve typecast attribute for write, its definition. Oh wait, hang on. This method also gets overridden in a different module, serialization, a third module. Okay, we resolve this, call super, back to write RB, and yeah, and I'm just already just like this. To be clear, we're not even close to be done to writing this attribute yet, and we've already traveled through 3 different modules. This is what it feels like debugging in ActiveRecord 4.1. These are all of the modules in ActiveRecord base. Literally any of these modules can possibly overwrite methods that we're working with. The logic was so spread out in these modules, the behavior leaks everywhere. It's just way too much. Which of the 6 places does define the same methods is the one that actually has the bug? They've said that these methods were just a nightmare to deal with. You would have like 6 different modules, all defining the same method and calling super. It was like spaghetti code. Like each noodle was a module. It was just a mess. Eventually, the logic boiled down to 2 hashes being created after this, before typecast and after typecast. You can see in before typecast, the key is the string ID, and then the value is the string 1, and then after the value has been changed into an integer. The road to get here, though, is unstable and has a lot of bugs. So this was Sage's first pull request in the spring of 2014. There were 37 files changed. So this is just their attempt at refactoring the typecasting. The problem was another person was already doing this work at ActiveRecord to make it less buggy. This is what it felt like to review that pull request. The maintainer of ActiveRecord wrote, please don't add more stuff to this PR. It's already like very big. Sage is only trying to refactor just how typecasting worked in ActiveRecord, which is just one piece of it. But like how we talked about, the behavior leaked everywhere. The first pull request was way too big, way too complex. Soon after, Sage was invited to Basecamp, where the maintainers of Rails chatted about working on the project. Sage worked through the summer and into the fall, making small refactor after small refactor. And this is the aftermath of that. I asked Sage, what was their North Star? Like, what were they trying to refactor all of this leaky code into? And they said, I was refactoring to something that managed state internally in a way that you would expect in Ruby. This means that instead of code spread out over the place, they wanted objects, instance variables, and methods that encapsulated that behavior and was easy to understand. Let's get back to our user example again. So remember, the value is 1, and we are casting the type to an integer. And this is the code after the refactor. You have the new attribute class and new type objects. So the attribute object holds the state, and then it asks the given type object how to do the conversion to and from its type. So put simply, Sage put the spaghetti code into a box called like the attribute object. The attribute object can now ask, hey, datetime, turn my string into one of your type. So these type objects now hold the logic for casting, and the attribute object delegates to them all of that behavior. So debugging went from digging through all of the noodles to, oh, we just used the wrong type objects. It's so simple. The code got re-architected in this more generic way. Entire classes of bugs just became impossible. This is an example of a small PR as a part of the refactor. So the refactor wasn't just one big PR, it was many, many PRs over a couple of years. So as you can see from this code comments, this one PR fixes all of these open bugs. In another example of bug fixing, Sage mentions that this feature like just works now. Like there were so many bugs and this just like closes them out. I asked them, what do you think was the hardest trade-off you had to make during this refactor? They said making the code maintainable initially came at a performance cost, and I'll explain. So I mentioned previously how the initial code resolved to 2 hashes before typecast and after typecast. So the work and memory of allocating 2 hashes is computationally small. So depending on after the refactor, now we're allocating Ruby objects. 1 attribute per column per record was a Ruby object allocated, these attribute objects. So depending on how many records you're reading from the database, these allocations can add up quickly. And allocating a lot of attribute objects is objectively going to do more work than just 2 hashes. So what's the scale that we're talking about? So let's look at our users table. Realistically, a real world user table is going to have like a lot more columns. Let's just say this user has 40 columns. So we'll do some math. So let's say we have an admin page and it's displaying 20 users. So you as a developer, let's say you're showing 3 attributes on this page, but maybe you didn't select just those 3 when you were doing your ActiveRecord query. So ActiveRecord grabs all of your attributes. And so 20 users times 40 columns is 800 additional Ruby object allocations. And so allocating 800 Ruby objects for 1 page is a lot more work than 2 hashes. One of the low-hanging fruits for performance gains was, instead of allocating all the objects, changing the code to only instantiating the objects as needed. And after that change, we go from 800 to 60, which is a great improvement. And this is the comments this is the commit of that pull request. Sage said that they remembered spending several weeks on performance, and they clawed it back to the point where, so this refactor, remember, was released in 4.2, and by the time that 4.2 came out, there wasn't a significant performance regression and performed about the same. I asked Sage about their thoughts on the importance of maintainability. They said that they're of the opinion that if code is buggy and unstable, it doesn't really matter how performant it is. If you're doing the wrong thing fast, you're still doing the wrong thing. You need to try to be a good steward to other people. Other people, include yourself, a month from now. When you make the code easy to reason about, you make it more stable. Code that is hard to follow will attract more bugs, especially when more hands are touching it in open source projects. The more people you have working on the thing and the more hard it is to follow, inevitably there will be more bugs. Maintainability comes through making information easier to find. So, for example, in writing this talk, I went back and looked through a lot of Sage's old commits, and they did a great job of making sure that any change they made was well documented in terms of the thinking that they had at the time and the context that they had at that time. So this is an example of that. This is actually like a very small change in terms of code, but it's a very thorough commit messages, giving just all of the context that they had at that time. And it was really only possible to write a kind of talk like this, given all of the context that Sage provided at that time. Keep in mind, this was like 11 years ago, like 10 years ago. Finally, I asked Sage about their thoughts about contributing to a large open source project like Rails. For context, this refactor that Sage did was a lot of pull requests. Obviously, the 1453 wasn't just this from this refactor, but they have a lot of experience to give when it comes to contributing to open source projects like Rails. So they're still number 15 after all these years. They said that for open source project that a lot of people use, stability is essential. We don't want upgrading Rails versions to be painful. So for context, upgrading from Rails 2 to 3 and then 3 to 4 were really painful. There were a lot of deprecation warnings, a lot of things changed. It just wasn't very stable between versions. Around the time that 5 came out, the core team started taking stability much more seriously than previous versions. If your public APIs aren't stable and upgrading is painful, people will stay on old versions, and really don't want people to stay on old versions because there can be things like old bugs and old things that get fixed in newer versions that they're not going to go back and change older versions to fix those. So I asked them what were like best practices for being a helpful contributor to open source projects. It's a more recent example, but please don't take like an open issue and then ask an LLM for how to fix it and then just open a pull request with that. It actually happens a lot more currently at this moment than you might think. So please don't do that. Read the contribution guide. They will tell you what they need. Like every project will have a contribution guide. Please read that. In the same vein, contribute how the project would like you to contribute. This can be like triaging open issues, merging pull requests. There's a lot of very helpful things that you can do without writing a giant pull request. They're just people working on these projects. So go and talk to the people on the team. Don't be like Sage on their first pull request. Don't come out of nowhere with this project you've been working on for weeks. It's most likely going to be closed and you've kind of spent all that time on something that's probably not going to be merged. Write code that's meant to be read by another human. So that was a great example from Sage's refactor, going from something that it was impossible to hold your head around to something that could actually be followed pretty easily. They said that they think the most impactful work from this refactor was making ActiveRecord easier to use. Thanks, everybody. I'm at thoughtbot, and the art for this talk was by Lyra Lim. Thank you, everyone.